So again, for those of you that are just joining, I'm asking that if you were able to come up with the answers to the left Riemann sum and the midpoint Riemann sum from yesterday, if you could drop those answers in the chat box to me privately. I just want to kind of see where everybody's at with your answers. And then we're going to go over both of those. Okay, I still have a few more answers coming in. That's fine. I'm going to go ahead and start going over the left and the midpoint. But if you haven't had a chance to answer, go ahead and you can still answer in the chat box while I'm sharing my screen. Okay, so we drew the picture for the left Riemann sum, and then to calculate the area, I'm going to try to color code this one again like we did yesterday. I'll start on the left-hand side this time. And if I want to know base times height, base is still going to be 1 because I have 4 rectangles and my interval is 0 to 4. That's how I know the base. So for this rectangle here in blue, I'm doing 1 times the height is actually going to be the y value when x equals 0. So let's call this f of 0. That's going to be the height. Was our function called f of x? Yes, it was. Okay. So to save me some writing, I'm going to do 1 times f of 0. And then I'm going to add to that another base of 1. This rectangle has a height of f of 1. So you just take 1 and substitute it into the original function. And again, those of you who are just joining, I've asked you to answer the left and the midpoint sums in the chat box while I'm working through my third rectangle here. I'm going to do in brown. Base is still 1. This height is going to be f of 2. So it's the y value on that curve when x equals 2. And then finally, the last rectangle also has a base of 1. And this height is actually going to be f of 3. And so if you punch those in your calculator like we did yesterday by subbing in, again, we're using up here at the top, we're using this f of x function, which is negative 1/2 x squared plus 8. We're using that function to get the heights of all of those rectangles. And remember, yesterday we typed that into our y sub 1, and then we just recalled y sub 1 and told it to evaluate at 0, 1, 2, and 3 would be the x values we use today. Now, I do want to point out that yesterday, notice that yesterday we used f of 1, we used f of 2, we used f of 3, and we used f of 4, which was 0. So the reason I'm pointing this out is because on the AP exam, usually when they ask you a Riemann sum question, it's usually in a table. And you don't want to waste time plotting the points to figure out what the base and the height is and which ones you use and which ones you don't use. So I want you to notice that for the right Riemann sum, we're starting on the right-hand side and we use 4, 3, 2, 1 to get the heights. We sub those into the original function. But over here on the left Riemann sum, we start on the left-hand side and we use the 0, y value in x equal 1, y value in x equals 2, and then the y value in x equals 3. You don't actually evaluate the y value when x equals 4 from the right endpoint. That's going to become important when we start looking at tables here in a minute. So either way, your answer, if you type that one in your calculator, your answer should be 25. And I think most of you had 25 for your answer, which is awesome. And that is, of course, units squared. But 25 is what I'm looking for. I'm just scrolling back through the chat box. Okay. All right, let's look at midpoint because a lot of you guys had gotten the left endpoint, and a lot of people got the midpoint as well, but I think more people probably missed the midpoint than the left endpoint, so let's make sure that we go over that. Notice the big thing about the midpoint here is that the number of rectangles, N stands for the number of rectangles, and the number of rectangles that we're going to use is 2 this time. We're still approximating the area between 0 and 4. So if we only need 2 rectangles, then in that case, our base is going to be a base of 2 this time instead of a base of 1. So what I'm going to do to construct my first rectangle is I'm just going to show down here sort of these little tick marks where my bases are going to be. And I want to show you that if your first base runs from 0 to 2, then the midpoint between 0 and 2 is going to be 1. So that 1 is actually what determines the height of your first rectangle. So you start right here at 1, and I'm just going to put these little tick marks because I know you can't see my hand. So I'm going to go up, up, up until I hit the curve when x equals 1, and that's going to tell me where to mark my first height for my first rectangle. It's going to be through that point when x equals 1. So the base of that rectangle is 2, and the height is going to be whatever the y value is when x equals 1. So now for my second rectangle, I start over here at 3 because 3 is the midpoint between 2 and 4. And so I go up, up, up until I run into that curve again. And then I make my rectangle the height of that y value. So those are my two rectangles. Now, once I have my two rectangles, then I'm going to calculate my area. And so my base, as I said, was 2. And the height of this rectangle is going to be f of 1. Again, just so we're clear, f of 1 is found by taking 1 and substituting it back up into that equation that we were given, because that equation is this little blue curve that you see that we're approximating the area under. That's what the blue curve is. It's that function f of x, which was negative 1/2 x squared plus 8. Parabola opening down, shifted up 8. All right, so that was the first part. And then for my second piece, let's do a different color here. Let's do this brown. We're going to add on to that another base of 2. And then the height this time is going to be f of 3. It's going to be the y value on the curve when x equals 3. And if you punch that into your calculator correctly, you should get 22 for that one. So those are all called Riemann sums. We started with the right Riemann, we moved into the left Riemann, and then finally we get the midpoint. So as I was mentioning, on the AP exam, whenever you are asked to calculate a left-right midpoint sum, usually they'll give you a table. And we're going to actually look at a couple of recent free response items where they ask you to find the Riemann sums using a table. But I wanted us to go back over this idea of drawing the graphs to help us approximate the area under the curve, so that when we do the table problems, you have this visual in your head and you remember how the Riemann sums actually work. So at this point in the game, we all know that the area under the curve, we can find the exact area under the curve using an integral. So these Riemann sums are a way of approximating what the definite integral gives us exactly. But a lot of times on the AP exam, at least 2 parts of a free response will be asking you to come up with a left, right, or midpoint Riemann sum, sometimes even a trapezoidal sum, which is what we're going to do next. But before we move into the trapezoidal sum, I do want to revisit our justifications. Now, my internet is lagging a bit, so it's going to take a moment for me to get down there. But yesterday we talked about justifying over versus under approximations, and it all depends on whether or not the graph or the function is increasing or if it's decreasing. So we filled in this little chart to help us with left and right Riemann sums, and we said that if f of x is decreasing, then the left Riemann sum gives us an over approximation. So on your AP exam, when they ask you that question, this is going to be the sentence that you write. When they ask you, okay, evaluate this area using a left Riemann sum, and then they'll say, does this approximation overestimate or underestimate the actual area? And your response is going to be based off whether that function is increasing or decreasing. And in a table, what that means is if your y values are getting bigger, that means the function is increasing. If your y values are getting smaller, then of course the function is decreasing. And so if your y values are getting larger and you're using a left Riemann sum, then what you would say is that your left Riemann sum is an under approximation of the area since f of x is increasing. And that would be all you would need to state to get that justification point. So before we get into the trapezoidal sum, let's actually look at a free response item from 2017. Now, if you have printed off the packet that I posted for you, then this should be towards the end of your packet. It is the first free response in the packet, though. If you didn't print it off or you don't have a printer, no big deal. I would just make a note on your own paper that this is from 2017. So this was an actual free response item. This is a complete free response item that was asked back in 2017. You can see we have a table problem here. Now, the only parts of this problem that we're going to be discussing today is going to be parts A and B, because those are the only two parts that deal with Riemann sums. And that's what we're reviewing this week. So we're going to focus in on 1A and 1B. So let's look at the stem. The stem says that a tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h feet is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Select values of, or select values for a of h are given in the table above. So that's the stem. And as you can see, they write these very sophisticated prompts and stems for each of these free response items that give you a lot of information and can sometimes be considered confusing. So let's see if we can decipher what they're wanting us to do by reading each individual question. So look at part A with me. Part A is asking us to use a left Riemann sum. They're wanting us to use 3 subintervals. Now, something I haven't mentioned today is that even though the subintervals that we used on our graphs for the instruction, the skill builder, were equal distant, that's not always going to be the case. So it's possible that your rectangles will have varying bases. In fact, in this particular example here, the bases have different widths. So the bases will not always be uniform, and that's important to note. So it does ask us to use 3 subintervals indicated by the data in the table, and it wants us to approximate the volume of the tank. And then it does ask us to indicate the units of measure. So when you are writing this, what you want to do, I'm going to see if I can find a space sort of above to squeeze it in. Now, on the actual exam, they usually give you, like, they'll do part A question, and then they'll give you a box to answer that in, and then part B and another box. I'm not sure how it will be set up this year, but that's typically how it will look on the exam. So let's do part A, and I'm going to put part A way up here in the left-hand corner to try to avoid that box of me if it's covering the right-hand corner of the screen. So what you want to do is you're asked to approximate the volume. And so what you're doing is you're approximating the integral from 0 to 10 of that function a of h. So we're going to write down the integral from 0 to 10 of big A of h dh is approximately. because remember, when you do a left, right, midpoint, trapezoidal sum, what you're actually doing is you're approximating a definite integral. So you really want to start by telling what definite integral you are approximating. Well, we're approximating the area under this curve A of H, and our interval is 0 to 10, as indicated by the endpoints of that interval in the table. So that's how I came up with the definite integral. Now I'm going to jump straight into my Riemann sum. Since it's a left Riemann sum, I'm coming from the left-hand side. And so the base of that first rectangle is going to be the distance between your first 2 points. So the base of the first rectangle is going to be 2. The base of the next rectangle is going to be 3. And the base of the third rectangle is going to be 5. So the base is the distance between, let's say bases, the distance between the x values when you're talking about left, right, or midpoint sums. So now I'm going to grab my first base of 2, and the height is, since it's a left Riemann sum, you start on the left-hand side of the table. So on the left-hand side of the table, bear with me for just a second, I've got to, okay, there we go. Left-hand side of the table, we've got this 50.3. And then I'm going to add to that my next base is going to be a base of 3. And that height is going to come from the y value when x, or in this case, h, equals 2. So it's going to be 14.4. And then I'm going to add to that my next base, which is 5, and I'm going to multiply that times the height, which is 6.5. So I should point out that when you're doing a left Riemann sum, you are not going to be using that rightmost height value. You're not going to be using that rightmost value. Okay, so this, what number was this? This was number 1. So number 1 is a calculator problem. So remember, on former exams, numbers 1 and 2 were calculator active, 3 through 6 were no calculator problems. So I know this is a calculator problem, and it did ask me to indicate units. So because I'm talking about the volume of the tank, I know it's going to be in cubic feet, and that was given away to me. Approximate, actually let me use a different color right here. Approximate the volume of the tank. And here I see that H is measured in feet. And so I could stop here and say feet cubed. And because I have a numerical answer, I don't have to simplify that any further. If you do simplify it, you end up with 176.3. So let me be very clear about this though. If you skip this middle step here, if you don't show base times height plus base times height plus base times height, if you do not show that step, you will lose a point. Okay? So make sure you do a couple of things with these types of problems if it shows up on the free response portion, which all of your questions are free response. So it's a good possibility that you will see something like this. Make sure that you label the integral, the bounds, using the bounds from the table, and then make sure that you actually write down the product, the sum of the products. And that will earn you, it turns out this particular year, I'm looking at the scoring guide here, they gave 2 points for that particular part of number 1. So 2 points. Now, it did ask you to give units there, but I will tell you that this year it asks you for units in parts A, C, and D. If you use the correct units in all 3 parts, A, C, and D, that actually earns you an additional point. So if you left off the feet cubed on any part A, C, or D, then you lose one of the points there. So that was part A. Part B is also dealing with Riemann sums, even though it doesn't say directly. Part B says, does this approximation in part A overestimate or underestimate the actual volume in the tank? And then it says, explain your reasoning. And at this point in the game, we all know explain your reasoning means write a sentence. So I'm not asking you guys to write the sentence for me in the chat box, but what I would like for you to do is to think about whether you think it's an overestimate or an underestimate, and simply type over or under to me in the chat box. Whether you think it's over or under. Great job so far, guys. I'm getting a lot of great answers, a lot of good responses. I don't see anybody that has missed it. The answer is, in fact, over. And so the way that you determine that, again, is it's based on 2 things. You have to take into consideration what type of sum that you're using. And if it's a left or right Riemann sum, you have to look at your table and see if your function is increasing or it's decreasing. And this function is decreasing because the y values are getting smaller from left to right. That's how I know that. But here's what we're going to write. So I'm going to go back up here so I have a little room. So this was part A. Now for part B, I'm going to say overestimate. Since A of H is decreasing. And that's only going to earn me a point, but I tell you, those 1 pointers add up. It's an overestimate since A of H is decreasing. Now, here's a couple of things that you want to avoid. You want to make sure that you don't use pronouns. We don't want to say overestimate since it is decreasing. The scorers are going to claim they don't know what it is, what you're referring to. You don't want to say overestimate since f is decreasing, because this function's name is not f of x. Oh, I'm getting a little bit of feedback. Can you guys hear me okay? All right. So you want to be very specific in saying the name of your function and whether or not it's an over and under estimate. So it's an over estimate since A of H is decreasing. Excuse me. It wouldn't hurt if you also said, since it's a left Riemann sum, but I don't think they would penalize you for not pointing that out, since obviously it's asking you for the left Riemann sum. As long as you state that A of H is decreasing, I believe that you would earn that second point, or that point for part B. That would actually be your third point that you would earn on this particular problem. All right, so let's go back up to talk about trapezoidal sums. It's going to take me a minute to get there, but I'm going to go up and talk about trapezoidal sums. Hi.
Can I have a snack?
Yes, you may. Can you get it?
Uh-huh.
Okay. All right, slowly but surely, it's making its way back up to the top. So what I'm doing now is I want us to look at the trapezoidal sum for n equal to 4. Back on our 6.2 skill builder. And slowly but surely, I know guys, I'm sorry. This is real life. Hi.
What did Hannah ask you?
For a snack. You can have one too. And you all go back downstairs, okay? All right, this thing is still rolling up to the top. While it's rolling up to the top, I'll remind you that to use the trapezoidal rule, there was that big, beautiful formula, but looked super, super complicated that we could use for trapezoidal sums when you have bases that are equidistant like these on this particular skill builder. But really, I think the best thing to do for trapezoidal sums is to just make sure you have the area of a trapezoid formula from geometry. Make sure you have that formula memorized. So I'm going to jot that down over here in on my skill builder. Just trying to move some stuff out of my way here. All right, so on your skill builder or on your own paper, if you would like, remember that the area of a trapezoid is 1/2 times base 1 plus base 2 times the height, or some version of that formula.
Can I go upstairs?
Take Hayden with you. It's okay. Take Hayden. Is she downstairs? Okay, you can go upstairs. That's fine. That's okay. Go ahead.
I'm gonna go upstairs.
All right, so if we use that formula, notice how it says that n equals 4. So in this case, n equals the number of trapezoids. So I'm going to build me some trapezoids. So I'm going to put points along the curve where x equals 1, 2, 3, and 4. And also 0. So I put my points there on the curve, and I'm going to build a trapezoid using some different colors here. So I've got this trapezoid in purple. Then let's build one in red. Then I have another trapezoid. I'll build it in blue. And then my last trapezoid actually looks like a triangle, and it is. excuse me. So now I'm going to find the area of each of those trapezoids and I'm going to add them all together. Now, one thing that I should point out that some students get confused on is that this time the change in x's down here at the bottom, this distance here, is no longer considered a base. It's actually considered the height of that trapezoid. So the change in x's is the height of the trapezoid. This distance over here turns out to be base 1, and then this distance over here turns out to be base 2, or vice versa. It doesn't matter which one you call 1 and 1, or which one you call 1 and which one you call 2. One of them is base 1 and one of them is base 2. So to find base 1, you're just going to find f of 0, the y value when x equals 0. And for base 2, you're going to find f of 1. The y value when x equals 1 is going to give you base 2. Okay, so let's sub into the formula. We've got area equals 1/2 times, let's say, f of 0 plus f of 1 times the height, which happens to be 1. And I'm going to underline that in purple because that is representative of the purple trapezoid. Then I'm going to add to that the area of the red trapezoid. So that's going to be 1/2 times. Now, the base 1 for that is going to be here. This is going to be base 1, which happens to be f of 1. And this is going to be base 2, which is f of 2. Yes, baby. I've got about 20 minutes, okay? Okay, so now I'm going to do f of 1 plus f of 2. And then that's going to be multiplied times the height, which again is just 1. Again, like with the Riemann sums, the height and the bases are not always going to be uniform. In this case, they are. But usually with a table, they're going to be varying widths and heights if you think about trapezoids. So I'm going to underline that in red. And then I'm going to do the blue. So now f of 2 is my base 1 and f of 3 is my base 2. And so I'm going to multiply that times the height, which is still 1. And I'm going to underline that in blue. And then for the last one, you can do a triangle formula if you want, or you can write it as 1/2 times f of 3 plus f of 4 times 1. Both will give you the same answer there. So again, 1/2 f of 3 plus f of 4, and that is times 1. Okay, so then if you type that all in your calculator, it makes it so much easier if you have your function f of x stored into y sub 1, and then you can just type it in as y sub 1 of 0 plus y sub 1 of 1, and so on, all the way down to the end. if you're typing it in the calculator. Either way, when you type that one in, you should get an answer, my friends, of 21. So you may want to just check that out later when we log off. I'm not going to punch it in the calculator just for sake of time, but it should spit out 21 for the trapezoidal approximation. Pretty close to the midpoint. All right, let's see here. Let's go on down to the justification page. It's going to take me a moment to get there. While it's scrolling down, I'm going to just check in on my chat box here. Oh. Just to see if y'all have any questions. Connor needs a snack also. All right. Shoo, finally, we got there. Justifying over and under approximations. Now for this sheet here, when you're talking about if the trapezoidal sum is an over approximation versus an under approximation, it all depends upon the concavity actually. So for Riemann sums, left or right Riemann sums, if they ask you about over or under approximation, it depends on whether the function is increasing or decreasing. If they ask you to do a midpoint sum, they're not going to ask you whether or not if it's an over or under estimate. But if they ask you a trapezoidal, they could also ask you if you're dealing with an over or an under estimate. And it's all dependent upon the concavity. Lost my lid here. Here we go. So notice in that last example, our graph was concave down. So remember with concavity, this is concave down, and this would be considered concave up. If you think about pouring liquid from above, and the graph would hold that liquid, that's concave up. And then for concave down, it would just roll right off. So it depends on the concavity. So you notice on our skill builder, we had a concave down graph, and our trapezoids underestimated the actual area. There was a little bit of space that was missing from the actual area, if you remember. So a trapezoidal sum is an under approximation of the area. We're going to write when f of x is concave down. And I would put in parentheses over here, that also means that f double prime is negative. So similarly, if you have an over approximation, that means that your original function f of x is concave up. So these are the sentences that you would need for your justification. Should the free response ask you whether or not your approximation is an over or an under estimate. So now let's look at an example, an actual free response item from 2018, and how we can answer that. How am I doing on time here? Okay. All right, so now this is number 4. This is a non-calculator question. And the two-piece, actually there's only one part, I believe. Yeah, there's one part to number 4, where you're asked about a trapezoidal sum. So look at number 4C. Again, since it's number 4, there's no calculator usage allowed. You're dealing with this. Let's read the prompt. The prompt says the height of the tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. So we've got a table problem again, very similar, but in part C, this time it asks us to find a trapezoidal sum. Now you don't have a graph like we did on our skill builder, so you kind of have to think about how that graph works and think about what you would use for your base 1 versus base 2 versus your height. And we're going to use 4 subintervals, and we're going to do that to approximate the average height of the tree over the time interval 2 to 10. Now, I'll go ahead and tell you that if this were on the AP exam this year, I don't believe they would say approximate the average height of the tree, because that is coming from Unit 8 using the average value formula. But I still believe they could put a question like this on there where they ask you to approximate the height of the tree over the interval 2 to 10. Okay, so we're going to play along though, since this was an average value formula, and I'm going to put it up here in the top left hand corner. This is number 4C. And because it had the word average height, we knew that we were going to be, oh, it's not writing on there, is it? All right, let me share again. Technology is wonderful. I love it. Sometimes it doesn't work exactly how we want it to, but I think we're back in business. Okay, so the word average height, is cueing me to use the average value formula. Again, average value formula was 8.1. You guys aren't going to be tested over average value formula. However, you are still possibly being tested over trapezoidal sums. So this is still a good question for us to go over. So remember, the average value formula is integral over interval. So you're doing the integral from 2 to 10 of h of t dt. Now notice on the last one, I called it a of h dh. Whatever your variable is inside the parentheses, that's what you're going to integrate with respect to. So we're doing the integral over the interval 10 minus 2, and we're doing that again since it said average height. So now the next thing that I'm going to do is I'm going to say that's approximately equal to, I'm going to pull out 1 over 8 and move that out of my way, because multiplying by 1/8 and dividing by 8 is the same thing. So I'm going to put that 1/8 out in front and forget about it for a moment. And I'm going to evaluate this or approximate this integral from 2 to 10, and I'm going to do that using a trapezoidal sum. Now, when you look at your table here, it said to use 4 subintervals. So we've got 1, 2, 3, and 4. So we've got 4 subintervals. And now the distance between those t values is not going to give you the bases. Excuse me, that's going to give you the height of each trapezoid. So between 2 and 3, there is 1. From 3 to 5, we have a height of 2. From 5 to 7, we have a height of 2. And from 7 to 10, we have a height of 3. So those are the heights. when you're dealing with trapezoid rule. Those are the heights. And so now if we start our formula, we can do 1/2. I'm going to do this in green. So 1/2. And then base 1 is going to be 1.5 plus base 2 is going to be 2. So I'm going to use this and this for my bases. And then my height is just going to be 1. Then I'm going to add to that 1/2 times. Now base 1 for the next trapezoid is going to be 2 again, plus 6, and the height is going to be 2. So I used this 2 and this 6 for my bases. So these values are giving me the bases. And then I'm going to add to that 1/2 times 6 plus 11 times a height of 2. And then I'm going to add to that 1/2 times 11 plus 15. Notice I used all of my y values times a height of 3. Now I did use all of my y values, but I also want to point out that I used all of my y values twice except for the very first y value and the very last y value. I only use each of those one time. Oh, and I hope that you guys that are watching this back on the recording later, I hope you all can see what I was writing there, because I know that my picture's up in that top right-hand corner. So hopefully, I've scrolled down now, so hopefully you can see that. Okay, guys, so I'm looking here at the scoring guide just to remind myself how it was scored. And it says that we get 1 point for the trapezoidal sum and 1 point for the approximation. So what that means is if you, let's say you knew how to do the trapezoidal sum, but you didn't know, you didn't really think to do the average value because you just thought trapezoidal sum and you went straight for what we have inside these brackets right here. So you can earn 1 point for just the trapezoidal sum. But then if you knew to do integral over interval and divide it by 8, that particular year they gave you 2 points. Now again, I don't think there's going to be an average value formula problem this year because it's from Unit 8, and they've already told us that they're not testing us over Unit 8. We'll find out more information on Friday, which I'm super excited to hear. Okay. All right, so here's what I'm going to ask you to do for tomorrow. So tomorrow we're offline, and I'm going to ask you guys to try, let's see, do I want you to try? Let's try 2B on 2019. So 2019 number 2B. I think I have sisters fighting upstairs. I'm going to have to attend to here in a moment. But 2019 2B, and then let's see, let's do 2016 1B. So those are the two that I want you guys to work on for me tomorrow during your class time. I called it lab time because that's what I call it in dual credit. But those two problems, those are the ones that I want you to work on tomorrow. And then when we meet back online on Thursday, we'll go over those, and I'll probably start class like I did today and ask you to put your answers in the chat box for me so that I can kind of see how you're doing with it. And then I'm hoping maybe we can start a new big topic on Thursday if we get through these two. Maybe we'll get to start a new big topic before we go to spring break. Now Friday you will have another short quiz to submit. I'm thinking it will probably be very similar to what we did this week, as far as I'll post it and give you some time and a deadline to submit that back to me. Okay, so I've got a question here in the chat box. Are we supposed to initial that Google Classroom post again today? And the answer is no. I'm asking that you only initial the Google Classroom roll call post one time per week. So I will post that roll call every Monday that we're in class or in school, and you only have to post your initials one time per week. So I won't post one next week because we're going to be on spring break. But the next week on Monday, I'll do it again. I'll post a roll call, you initial one time for that particular week. And it's just to help me keep track of attendance for the board office, that I have to send information into the board about attendance virtually. So that's why that's my attempt to kind of keep that organized and in one spot so that I can quickly check off your names that I'm having contact with you for the board. And then of course I'm keeping my own information separate from that. But yeah, that's all I have for you guys today. Any other questions before we log off? Anybody willing to turn their video on so I can see some faces today? Ah, there's some. Let's see here. I'm going to see if I can get my. There we go. Hi, yay. Thank you all so much. Those of you that are, let me see your faces. It's lonely with the little black boxes and you guys' names. Hi. All right, guys. Love y'all so much. Take care. I'll see you on Thursday. Mwah. You're the best.